Okay, a wee bit of weird science going on here. So this is a single gearbox version of the gearbox kit you get from Jaycar. They've got the motor specs on the website, and apparently the motor is it's around about 8 centimeters of torque. And I was trying to work out how much load this thing could carry, and I'm still going to do the calculation, but I thought let's do a sort of a high school project here. So what I've got here is the motor is operating this lever arm, and I've got a little container which has got a little bit of water in it at the moment, and hopefully my switch won't fall apart while I try and film this, but at the moment it's basically almost no load, and as you can see the motor readily lifts the load. So we're going to see how much water it can lift. Probably not much. So I'm just going to guess here because I have no idea how much water it will lift. Well, it definitely lifts that small amount there. I know you're all looking at this thinking it's going to fill it up and the water's going to go everywhere. And it probably will, but hey, there's a bit of fun. Still lifts that much. So this bottle I'm using for the container is a 1.5 litre, so we can basically guess the capacity, or hey, we could even measure it. Still going strong. That's actually pretty good. The power supply is a 3-volt 1.5 amp, and this motor I think has a stalling current of about 300 milliamps. Right, it is slowing down a bit there. I imagine that the weight of water that will actually make the motor drive the other way, that would actually fight the motor, is probably considerably more. Right, there we go. So that did move. I'll just do that again. But it can't lift any further. So that's my lifting capacity of this particular combination. Now I've still got to go away and work out what gear ratio I actually built this gearbox for, because they come as a kit with a variety of ratios, and what that load is. But looking at the amount of water, I would guess that that is probably maybe, I don't know, 150 mils, 100 mils. So it's pretty much really expected it's between 100 and 200 grams, but we'll weigh that just now and see. Okay, back again. So I just weighed the water that we did that experiment with. It was 200 milliliters, slightly under. So we can say this particular combination can lift basically a 200 gram load. And just to complete the calculation, I can find a ruler I can actually read. We need to know, in order to work out torque, the length of this arm, which is 20 millimeters. So I've got 20 millimeters and 200 grams. And, oh, what's that? That's 4 kilogram centimeters. Which is, oh, I've got to work this out. What's that, about 4 Newton meters or something crazy like that? It's not bad. It's not bad. With the gearbox we're intending to use being 2 of these, we can obviously sort of double that capacity, but it does mean we have to be careful about weight. So yeah, just a different way of looking at things, I guess. And the chip packet is not mine.